The Golden Dome Missile Defense Initiative is one of the most ambitious and controversial programs in the history of U.S. strategic defense policy. It represents a dramatic shift from traditional ground-based and sea-based interception systems to a comprehensive space-based layer capable of detecting, tracking, and destroying ballistic missiles and hypersonic glide vehicles in space or at the edge of Earth's atmosphere. The program is being developed in response to the increasing threat posed by advanced missile technologies, including maneuverable hypersonic weapons, which can travel at speeds of Mach 5 or more and execute unpredictable flight paths. These weapons are designed to defeat or bypass existing missile defense systems such as the Ground-Based Midcourse Defense (GMD), the Terminal High Altitude Area Defense (TOD), and the Aegis Ballistic Missile Defense System. Because they can change trajectory mid-flight and fly at low altitudes or through near space, intercepting them is far more difficult than with traditional ballistic missiles. Golden Dome is being designed as a solution to these challenges. Its key concept is to deploy constellations of small, fast, and smart interceptors in orbit that can detect and engage enemy missiles very early in their trajectory, either during the boost phase, shortly after launch, or during the mid-course phase while traveling through space. This early intercept capability dramatically increases the chances of neutralizing a threat before it enters the atmosphere or nears a target. These interceptors will operate from satellites or other near-space platforms and be guided by advanced space-based sensors, including infrared and radar systems. Once a missile is launched, the Golden Dome system will track it using real-time data relayed from sensor satellites, then calculate a firing solution to launch a kill vehicle. The kill vehicle, a small, autonomous interceptor without an explosive warhead, will collide with the incoming missile at extremely high velocity, typically above 20,000 km per hour, destroying it by kinetic energy alone. The kill vehicles are expected to be highly maneuverable and use a combination of onboard thrusters, guidance software, and in-flight data updates to locate and hit their target with precision. These interceptors are also being developed with advanced artificial intelligence to improve autonomous decision-making in the final moments of flight, when human operators may not be able to respond quickly enough. Northrop Grumman is currently leading the technical development of these systems under contracts awarded by the Department of Defense in the U.S. Space Force. The company has already begun ground-based testing of the key components, including kill vehicle navigation systems, propulsion modules, and simulated intercept scenarios. These tests are taking place in highly controlled environments that replicate the thermal, vacuum, and kinetic conditions found in space. Initial results have been described as promising by defense officials. The United States has committed substantial funding to the project. In July 2025, an additional $13 billion was approved as part of a broader defense spending package, adding to prior funding allocated through what was known as the One Big Beautiful Bill Act. Total projected funding now exceeds $175 billion and could potentially reach over $300 billion over the next decade, depending on deployment timelines, contractor participation, and future expansions. An important development in recent weeks has been the shift in the program's commercial partnerships. The U.S. government had initially expected to rely heavily on SpaceX for launching Golden Dome interceptors into orbit. However, due to escalating tensions between SpaceX CEO Elon Musk and President Donald Trump, the administration has moved to reduce dependence on the company. While SpaceX remains technically capable of supporting the program, officials have begun pursuing alternative launch providers and satellite integration partners. Amazon's Project Kuiper, Blue Origin, Lockheed Martin, L3 Harris, Rocket Lab, and other space technology companies are now being considered or have been formally invited to participate in various phases of the program. This diversification is intended to avoid political risk, accelerate innovation, and expand industrial capability across multiple regions in the U.S. This approach also aligns with the administration's broader space industrial mobilization policy, which aims to ensure that no single private company can bottleneck access to critical national security missions. General Michael Getlane, a senior Space Force commander and former head of the Space Systems Command, has been appointed to lead the Golden Dome program. He has stated that the complete system architecture, which includes interceptor deployment zones, sensor constellation design, kill vehicle configuration, and command control protocols, is expected to be finalized within 60 days. Early deployment tests are targeted for 2027, with full operational capability anticipated by 2028 if no major delays occur. One of the program's defining features is its attempt to merge missile defense with modern space warfare doctrine. Unlike previous programs that focused only on terrestrial or maritime interception, Golden Dome assumes that the future of strategic defense lies in orbital operations. The system is also intended to serve dual roles, not just shooting down missiles, but potentially defending critical satellite infrastructure from kinetic or electronic attacks. Despite these objectives, the program faces significant criticism and debate. Critics argue that placing weapons in space could destabilize existing arms control agreements, spark a new arms race focused on anti-satellite and space-based weapons, and raise the risks of accidental conflict escalation. Others question the cost-effectiveness of such a vast system, especially given the technical challenges of space deployment, maintenance, and reliability. Senator Ed Markey and other lawmakers have voiced concerns that the program could ultimately cost over $500 billion if sustained through multiple phases and integrated into global defense infrastructure. Some also point to the possibility that adversaries may develop countermeasures, such as decoys, maneuvering warheads, or satellite jammers, that could limit the effectiveness of Golden Dome or create vulnerabilities. Still, the Department of Defense maintains that this program is essential for staying ahead of emerging threats. Military officials have stressed that no other known defense system provides the global, persistent coverage that a space-based layer could achieve. The program is seen as critical not only for the continental United States but also for forward operating forces and allies who may face regional threats in the future. In terms of timeline, the next 12 months will be crucial. Final system designs, expanded testing including flight trials, contractor selection, and infrastructure preparation will all take place by mid to late 2026. If those stages succeed, interceptors could begin deployment into low Earth orbit and geosynchronous zones by 2027, with full integration into the U.S. Space Command's defense network by 2028 or shortly after. Golden Dome is more than a missile defense program, it is a strategic shift in how space is viewed as a battlefield and a critical domain of national defense. The combination of high-tech interceptors, orbital sensors, autonomous guidance, and layered command control represents a leap forward in defense capability. However, it also raises major questions about cost, stability, and the long-term implications of military operations in space.